Hello, I'm Mr. Brewer at Seven Lakes High School. Teach academic physics. This week we've been talking about thermodynamics and heat. In biology, you talked about fire being, is it alive or not alive? You talked about living characteristics. In chemistry, you talk about thermochemistry, how solids becomes liquids, liquids become gases, and there's some solids who become gases called sublimation. You get all that heat of vaporization and so forth, and latent heat. Now in physics, however, we deal with how energy as heat does work. In chemistry and physics, we talk about how my lava lamp, for example, the heat heats up the liquid, that's its carbon tetrachloride and wax, and heats it, expands, goes to the top, condenses, and sinks and goes down. Now, what does it mean in physics? Let me show you. Okay. In physics, we have high energy always moves to lower energy. We know that. So this is a hot topic, so I'm going to get ready. All right. So what happens here is internal energy is U. U are the system. In this case, U is the refrigerator. I can make U Gonzo here, or U is the refrigerator here. What happens here is this. Let's say we're going to study the system. That's U. What's happened to the internal energy of U? Well, what happens here, you're standing with the refrigerator door open, and it doesn't matter how long it takes, the choices don't change the longer you leave the door open. Take my word for it. I've tried. Okay? What happens is your heat, high energy, goes to lower energy. Well, the hotter person is you. That's why you can never, ever cool down your kitchen by leaving your refrigerator open. Again, tried that, it doesn't work. But what happens here is this. Heat goes into the system, okay? Let's see what happens to the heat and work. Now, work is force times distance. It's also change of kinetic energy. Let's see what happens to the work and change of kinetic energy here. What happens here is the molecules are in the refrigerator and I'm adding heat to it, which means they speed up, and if they speed up, they separate. So what happens here is this, is by separating, my distance between them increase and my velocity increases. Therefore, I have a positive work done on you, okay? Because it's gaining heat energy from the surroundings. On the other side too is what is happening to Q. Well, you're giving off heat. What's happening here? It's actually what's happening here is it's taking on heat. So if it's taking on heat, that means it's going to be a positive Q. Because it's taking on heat. Where's it taking on heat from? It's taking on heat from you because high energy moves to lower energy. And you got higher energy. You got your 98.6 degrees Fahrenheit or whatever, and you're going to a lower one. So high goes to low. So heat goes to low here. But what happens if things change a little bit? What if we do a switch here? Let me erase this and try this. What happens, for example, if U changes? What if U becomes U? Okay, so now you becomes the person here. What happens when you stand in the refrigerator? Well, we already know the refrigerator is going to get warmer because hot goes to cold. What happens here is this, is you're getting cold from the refrigerator. That means your molecules are going to get closer and closer together and slow down. So it means if they're going to slow down, that means my velocity decreases and my distance between decreases. Therefore, I have a negative work. So negative work is being done on you now. But you're still giving off heat. You're still giving off heat. So since you're giving off heat,